Hello, ladies and gentlemen. Mr. Cockburner back here. Um, Today's lesson, writing linear functions. Writing linear functions from a graph, from a table, and then with slope and y-intercept form. On your mark, get set, let's go. So the first thing is y equals mx plus b. I'm sure you've heard this before. Not your first rodeo with this. So what we're really going to be paying attention closely to is going to be this m and this b. The last time we talked, we called this rate of change, this m. Sometimes they call it slope-intercept form, but remember, another fancy way to say slope is the constant rate of change. And then b is going to be my y-intercept. So that's where we're going to be touching the y-axis. So those are the two mysteries that we're really going to focus on today and how to find those. All right, first thing is they're just going to give it to us in slope-intercept form. So let's just look at this. Whatever is besties with that x is going to be the m. That m, again, is that rate of change. So it's going to be positive 3. And this constant is called your y-intercept, or the b. Y equals mx plus b. So this will be positive 1. Again, this is just to go quickly through here. X's best friend is always going to be the slope, or that rate of change, and then the constant, the number all by itself, is going to be your y-intercept. And we're going to show you the importance of those two things here when we get to graphing next slide. So again, bestie 1/2, constant, the number all by itself, is positive 5. Here it's 3, and then our constant is positive 7. So just to give you a heads up again, that's the two things, the most valuable things that we need to pay attention to is going to be that rate of change, which is x's best friend, and then the y-intercept, which is the constant. Graphing a line. So where do you want to start graphing? You always kind of want to start your way backwards. So I'm going to start right here, and if you notice, I just took the problems from the last slide. I'm going to start at +1. Again, this is the y-intercept. So this is where it's going to touch the y-axis. So I'm going to graph that point right there. And then my slope, or my rate of change, are my driving directions. So again, I'm going to tell you fractions are going to be your friends here. What you're going to do from your y-intercept that you just plotted is go, remember, this is up, and then this is to the right because they're both positive. So we're going to go up 1, 2, 3, and then 1 to the right. And then from there, we're going to go 1, 2, 3, and 1 to the right, because we're going to constantly rate of change. So now I can't graph anything further to the right because there's nothing up here. So I'm going to go back down to my y-intercept, and I'm going to go down 3 and left 1, because if you notice, a negative and negative will make that positive slope still. So let's go from the y-intercept right here, down 1, 2, 3, left 1. You can plot that point. Down 1, 2, 3, 1 to the left. So now, I don't know why is that allowing me to write this big. We have our line function. I don't have a straight edge right now, but you can see that makes it a linear function because that constant rate of change of up 3 right 1 or down 3 left 1 gives us that nice linear function. All right, so where do we start from the next problem? Work your way from the back to the front. So +4 is going to be right here. The y-intercept. It's always going to be on that y-axis. That's why we're calling it the y-intercept. And then here we have -2, 3. So I'm going to write the -2 up top, and then the 3 in the denominator. So I'm going to go down 2 from my y-intercept, and then write 3. Again, down 2 from that point now, and 1, 2, 3 to the right. I can't go down 2 and write 3 because there's not enough room to go right. So I'm going to start back again at that y-intercept, the +4, and I'm just going to do the opposite. I'm going to make 2 positive and then 3 negative. And that's the same fraction. Those are going to be equivalent. So what does that mean? If the numerator is positive, you go up 2 to 6 there. And now we're going to go left 1, 2, 3. And again, we can't go up 2 because our graph doesn't go enough. So I'm going to connect those dots and make a nice linear function. So you can see that this is going uphill, the first one, and now from left to right, it's going downhill. So this is a positive slope or positive rate of change, and then this is a negative rate of change because it's going downhill left to right. This is going uphill left to right. Just a quick review on slope. Now we have a graph and we have 2 points. So what we are going to do is if it gives you a graph, remember, we have to find these 2 blanks right here. M is that rate of change. B is going to be that y-intercept. Here's your y-intercept. Be careful because it looks like it might go up different intervals, but it doesn't. Up 1, up 2, up 3, here's 4. So right now we are at 0, 2, so that's going to be my y-intercept where it touches the y-axis. And now what I like to do is I like to just count because I have a graph. I go up 1 and then right 1, 2, 3. The only tricky thing is, remember, it's the y's over the x's. So we went up 1 and right 3. So now we have our y equals 1/3 x plus 2 as our linear equation. So again, I always just like to do y equals blank x blank, and we need to fill in those blanks with the information provided. So let's start with our m, our slope or our rate of change. We go down 1, so negative 1, over 1, 2, 3, 4 to the right. So it's down 1, 4 to the right. So our top is negative, our bottom is positive. And now where do we touch? The y-axis is at positive 3. So y equals negative 1/4 x plus 3. And I just have these labeled here just to remind us what we were trying to find with those unknowns. Next. This one's a little trickier because what do you know about a horizontal line? So again, this is my slope, this is my b. If it's a horizontal line, there's no rate of change difference. So that's going to be a slope of 0, which is possible because you can still see that this is a line and it passes the vertical line test. We need to figure out what this y-intercept is, though. Where does it touch the y-axis? Is at negative 1. So we would rewrite this y equals, since there's no slope, we would just say y equals negative 1. Both are correct. However, as mathematicians, we like to write as little as possible because we're intelligently lazy, and we just have y equals negative 1 because we technically don't have a slope. We do, it's just a 0 slope. All right, so we do have a slope. I kind of misspoke there. However, it's just a slope of 0. All right, last but not least, here's another special case, y equals blank x blank. It goes through our origin, so our origin is plus 0. That's going to be our y-intercept. And then if we get our slope, we go down 1, 2, 3, 4. So negative 4 over 1, 2, 3 to the right. So this says y equals negative 4 over 3 x plus 0, or y equals negative 4 over 3x. And again, we are intelligently lazy, so we don't put the y-intercept. This is called direct variation. However, that's just a term that means it goes through the origin as the y-intercept. So y equals negative 4/3 x, and we don't need that plus 0. You could, it's not wrong, it's just doing more work than you have to. Error analysis. Describe and correct the error in the writing of the equations shown below. So they have y equals 3/5 x plus 4. I always just like to look at the y-intercept. I think it's fastest to do that, which is positive 4. So that's good. So where they messed up is probably the slope. And I can tell you right now, this slope is going downhill. So it's another quick check. From left to right, it's going down the sled riding hill, right? So if I look here, guess what? That's their mistake. I can tell you that right now. The numbers are right, except the fact that it should be a negative slope, not a positive slope. Let's just make sure. Down 1, 2, 3, so that's down 3. See how they didn't have that negative, they have a positive, and then over 1, 2, 3, 4, 5 to the right, which is still good. So their mistake was they kept this positive here when it should have been negative. All right. Error analysis number 2. Describe and correct the error in the writing and equation of the line with a slope of 2 and a y-intercept of 7. So what goes first? Y equals mx plus b. Slope with this bestie x, and then b is going to be my y-intercept. So in this problem, it says a slope of 2. So if you look, they just flip-flopped it. Our slope should be paired up with the x, and they had 7. And then your y-intercept should have been 7. So we just had to flip-flop those two values. So I'm just trying to figure out different ways that a test might come up, and they could ask you different questions. So this is from a table. What is the rate? We did this last homework assignment. So how do we go from 3 to 7? We added 4. How do we go from 7 to 11? We added 4. How do we go from 11 to 15? We added 4. So my change of y's is 4. And now my change of x, remember y is always on top, x goes on the bottom. From 0 to 1 is plus 1. From 1 to 2 is 1. And from 2 to 3 is 1. So that is going to be my slope, or my rate of change is 4 over 1. Or just 4, because we're intelligently lazy. We don't need that dividing by 1. What's our starting value? What do they mean by that? They mean what's our y-intercept? Where are we starting? So right here, remember, you don't move left to right because you're on that y-axis. And then you just go up 3. So now if we write our equation, we get y equals, this is our 3 value here. So y equals, we got to fill in our blanks. We filled in that 4 here because that's our rate of change. And then our starting value is that positive 3 because we know that we don't move left to right on the y-axis. All right. So we get y equals 3x plus 3. Here, what's the rate? Remember, we start with the y's first. 0 to 6, positive 6. 6 to 12, positive 6. 6 to 18, 18 to 24. So we're plus 6 on top. And our rate of change, negative 1, or positive 1, positive 1, positive 1, positive 1. So our rate of change is 6. What's our starting value? We're looking for x as 0 because we're not moving left or right. We're just moving up or down on that y-axis. So hit partner here is 12. So we write our equation, y equals, fill in our blanks. Remember, rate of change goes first, and then our y-intercept goes second. So these kind of go pretty quick once you get the hang of it. Again, if you need, I always say it, if you need it, pause it, rewind it, re-listen. If you have questions, email your teacher because we will help you. We are here to build confidence. All right, so here we have what we call point slope form, all right? Because what we're going to do, we should put a point slope form. All right, so what we're going to do is fill in the blanks here with our points, and then we're going to also fill in our information with our slope. That's why it's called point slope form. If you look, we have y equals x, and then we're going to have b here. So you can kind of see how it's still the base skeleton from y equals mx plus b. However, we are going to now use points to help us out. So first things first, it's always y minus, and then we're going to leave some space. So what goes here is our y1, and this is the tricky part. Where's the y? I like to label these as well. So our y goes with on the left side, which is 1. Oops. Which is 1 here. And then our slope is next with our m here. So I'm going to put 4 there. And then our x value there is negative 1. So if we clean that up, we have a negative and a negative, double negative right here. So we get y minus 1 equals 4 times x plus 1. All I did was clean up that double negative. And now what do? if you recall, don't call me after midnight, right? We're going to distribute first. So we're going to get 4 times x is 4x. 4 times 1 is positive 4. We didn't do anything to the left side, so we're just going to keep that as is. Now we're going to combine like terms, and we want that y equals mx plus b. So what we're going to do is add 1 here, because we're going to isolate the y value, and we get this flashcard of 0 here, so that is good because now we're left with y equals 4x. What's this flashcard? Combine like terms, right? 4 plus 1 gives us our 5. So here is our point slope, giving us our answer in slope-intercept form. Any questions? Again, I know I'm going quickly. We're going to do another example. However, if you do have questions, pause it, rewind it, and go. So again, our base is always y minus blank equals your slope x minus. So now we just need to fill in our information. Again, the tricky thing is that y goes on the left side. So here's our 3. Our m goes next, so we're kind of out of order. And then our first thing goes actually last in that example. So again, we have the double negative, so we have to clean this up. And we get x plus 2, and we get negative 1. And I'm just rewriting everything. Again, we're going to distribute, which just means take the opposite because we're doing negative 1. So it's going to be negative x minus 2. And I'm just going to recopy whatever I did not do over there. And now again, I want y equals, so I need to add 3 to both sides. And that plus 3 goes with the constant because it's the like term. Add that up, I get 0. I get y equals negative x plus 1. Circle it, because that's my final answer. All right, so here's the problem. They give us 2 points and no slope. So what do you have to do first? We have to find the slope. If you recall from last video, it's y2 minus y1 over x2 minus x1. So what I like to do, my preferred method, is I always do the minus, the division bar, and then the minus. And I just bunny hop these over top. So I put and make this a fraction, and make this a fraction. Sorry, this is a 5. So now I have 0 over negative 1, and I just put that ordered pair with y over top of the x, and I'm going to take that second order pair and just bunny hop it over the top. That negative 5 goes on top of the 4, and now I'm going to get the slope. What is 0 minus 5? 5. What is negative 1 minus 4? Negative 5. So my slope is negative 1. So now I'm going to choose to put it in y minus my point slope form. I know what my slope is, so I'm going to put that where it goes, and that goes outside of the parentheses on the right side. And now I have a choice. I always like to use 0 because 0 is easy to add, multiply, subtract, and you can't divide by it. So you can only do 3 of the 4 operations with it. So I'm going to use this value right here. All right, that ordered pair of negative 1, 0 to put in these spots here. So again, be careful because y goes first, even though it's last in the ordered pair. So we have 0 there. And then we're going to put our x in over here. Again, if you notice the common trend, we have to keep simplifying that double negative. And I'm just going to rewrite everything else because I didn't simplify it. And now let's distribute. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Equals 0 minus y on the left. Now how do you move 0 to the other side? You don't have to. It just simplifies. Because if you don't have any, look, you don't have any. It just says y. Equals negative x minus 1. And that is going to be it in slope-intercept form. So we put it in point-slope formula to then solve to get into slope-intercept form. Almost there. I know. Bear with me. All right, so now I'm going to just show you a quick way to do it with y equals mx plus b potentially. All right, so the last slide here was with point slope formula. This one is going to be with using y equals mx plus b. So again, we don't have the slope. So what we need to do, again, is y2 minus y1 over x2 minus x1. So you can label it, or I like the bunny hop method where I put the y over top the x. And again, for this problem, it doesn't really matter because they're the same. However, I just drop that first order pair down here, and I drop the second order pair behind it. And I'm going to get those to be negative, so I'm going to get a double negative here. Negative and negative get me a positive 2. So this changes to positive 2, so it's 5 plus 2 equals 7 on top. Again, I get my double negative here. So I'm going to change that to adding. 5 plus 2 is 7. So hey, my slope simplifies to 1. So again, I have this y equals mx plus b, and I'm going to have a choice. Do I want to do 5 comma 5 or negative 2 comma negative 2 as my y's and my x values? I'm going to plug in the 5 and the 5 because they're both positive. All right, so when I take that point, I'm going to plug in this 5 goes to that y. I just solved for m over here. M was 1. And I'm going to put this 5 here. And now I don't know b, so guess what I'm going to solve for? I'm going to solve for b. How do I do that? What's 1 times 5? 5. Plus b didn't get touched with, the equal didn't get touched, and the 5 on the left side didn't get touched. Now what happens? I subtract 5 from both sides because I'm going to isolate b, and I'm going to get b equals 0. So what happens here is when I get this, I just y equals blank x blank. So now I solve just like those first problems we did on this video. We're given the m and the b. Our m is 1 and our b is 0. So it can say plus 0, or we just write y equals 1x or just x plus 0. I don't like the way that wrote, so I'm going to erase that. And then we can put plus 0, but we're intelligent and lazy. So it kind of looks weird, but it says y equals x, and that's a true statement. All right, it goes up 1 and over 1 to the right through the origin. All right, now what we are going to do is make this example look like y equals mx plus b. In other words, we are going to make it say y equals. So right now, what's on the left side? 3x minus 2y equals negative 16. Yes, this is exactly what we did last week as well. So what I want to do is my final word should be y equals. The first 2 words out of my mouth should be y equals. Right now it's 3x. So how do I move 3x to the other side? Subtract 3x. Good. When I do that, this simplifies to negative 2y. Don't forget that negative, super important. Negative 2y equals, and then the constant always goes last, so I'm going to put negative 3x first, minus 16. Remember, these do not combine. These are not like terms, so we're going to keep them separated, just like an Offspring song in the early 90s. Good song. All right, so now we don't say y equals yet, we say negative 2y. So let's divide each term, because there's 3 of them. You have to treat them all fairly. Divide by negative 2. What is divided by, or negative 2 divided by negative 2? Y, or 1y, right? And then what's negative 3 divided by negative 2? Those negatives simplify, because 2 negatives make a positive, x. And then what does this simplify to? Again, we have 2 negatives, so it's going to change to a positive. What is 16 divided by 2? 8. So now we solve for y equals 3 over 2 x plus 8. Again, this is my rate of change, 3 over 2. And then my y-intercept, where I'm going to start graphing my graph on a coordinate grid, would be at positive 8. So up 8. So nice, let's do it again. We want to say y equals. The first words out of my mouth here are 4x. So I want that to move to the other side. All right? So I get negative 4 equals. I'm going to subtract negative 4 to move to the other side, inverse operation. And I'm going to get negative 4x plus 1, because these, again, do not simplify because they're not like terms. Now, I don't want negative y equals. I just want y equals. So right away, what I'm going to do is just change this to the opposite. What's the opposite of a negative? Positive. What's the opposite of this positive? Or this negative, I'm sorry. Positive. What's the opposite of this positive? Negative. Or, like you were probably taught, divide each of these by negative 1. And if you understand where I'm coming from, negative 1 divided by negative 1 is positive 1y, or just y. What's a negative divided by a negative? A positive, like we predicted. And then what's a positive divided by a negative? A negative. Good. So we're going to get our rate of change is x's bestie, so that's going to be 4. Our y-intercept, where we're going to start graphing our graph, is going to be down 1 or negative 1. All right? Any questions? I know it's a quick lesson. Again, pause it, rewind it, re-listen. We covered writing functions from a graph, writing linear functions from a table, writing linear functions from slope and y-intercept form. All right? If you have questions, please email your teacher, and we look forward to building your confidence and growing as a math student.